What's up, guys? So, I made metabolism in a factory game called Satisfactory. I'm using pathway planners from Seeking Health. Ben Lynch at Seeking Health designed these, and this has completely changed the way that I've started looking at health. Biochemistry seems like a pretty daunting thing to research and whatnot, but I'm about to show you it's actually really simple in a lot of senses, a lot of ways, and it's almost fun to learn because we're learning how to fix ourselves. Like a machine that can figure out how to fix itself is pretty cool, I think. And a really cool side effect is feeling better and enjoying life just a touch more. So this is gonna be. I'm gonna kind of fly around a bit and bounce around. I'm gonna make some better videos for you. I just have to build a new computer because you're gonna see mine can't handle this. My wife is buying me parts for a new computer for Christmas. But if you're able to, feel free to stop by buymeacoffee.com/unpilled and buy me a coffee, whether it's just one coffee or 10 coffees or buy me a coffee every month or whatever it might be. I could really use some kind of help making this stuff because I don't know if you can hear my computer fans in the background, but this is going to take some resources to turn into a viable project. So we're going to take nutrients in the game. They're coming from those machines, but these are nutrients that we eat. We're going to run them through this stomach acid thing. We're going to send them to digestion, and we're going to send them through this whole crazy methylation, bioptrin, glutathione, oxidation, crazy system. We don't really need to worry about how complex this is. We're just going to look at how the next piece depends on the last piece, and all the pieces connect to the knee bone or whatever it is. Stomach acid is commonly low, or stomach acid problems are pretty common. And of those stomach acid problems, low acid is common. We assume it's elevated acid because it burns, but the problem is when our stomach acid's low, it doesn't close the flap at the top of our stomach, and then the acid goes up there and it burns. And it's understandable to assume that we have elevated acid at that point, but that's not the case. Acid's really hard to make, so our body's not going to make a bunch of extra acid when it's having a hard time doing just about anything. So when stomach acid's low, we don't digest our protein or B12 well. Those two are very important in this because protein is very hard to break down, and B12 requires special situations to be happening. So when stomach acid's off, these two are inhibited pretty severely. There's some other nutrients that are involved, but they don't get hit as hard. Fat digestion is inhibited because when things are working properly, we send our acidic food that's been saturated in stomach acid down to our gut. Our bile is added to it at that point to neutralize it. But if we're sending it already neutralized because we don't have stomach acid, our bile can't be released, or it'll over neutralize it. Now it'll be basic and it burns us in the other direction. So that's a big problem because fat digestion is very important. We also don't release our digestive enzymes because that's part of the bile release. And I have a feeling if our pancreas is not able to make digestive enzymes well and release them, it's probably not doing a bunch of other stuff, which we're going to see in this system, how these things all depend on each other. And if one thing's not working, maybe something else isn't working because it's not making the byproduct that the other piece wanted or something. And oxalates can now be absorbed because when fat digestion isn't working properly, the fat now clings with the calcium in our diet, and the oxalates go into our bloodstream. And that's not good because oxalates are stones. And this is probably why people are running away from plant food. Everybody's like, plant foods are toxic. They have things that defend themselves. And it's like, yeah, well, if your stomach acid works, then that's not a problem because it hasn't been a problem until recently. So something changed, and it's not the plants. Well, yeah, the plants have changed, but it's not the oxalates in the plants. Stomach acid has some problems. I'm going to try to get these symptom lists and views so you can pause and read them if you want, but I'm not going to stop by each one. And one of these days I'll get the keys properly or get the right keys down, but until then I'm going to bounce all over in the wrong direction a lot, most likely. I've only been playing this game for like 400 hours to make this, so, I'm still getting used to it. So leaky gut is when food kind of just goes right through the wall of our gut because it's not being held together properly because it doesn't have nutrients it needs. So these are some problems we run into from this. This is somewhat common. This is what is probably causing a lot of people's allergies and skin rashes and all types of stuff. But poor fat digestion, we're going to run into these issues. And lack of protein, we run into those. And the reason that I list these right here is because if our stomach acid doesn't work and we're not digesting properly, this stuff right here is most likely happening. It kind of, these things can't function properly when our stomach acid is not working and we're not digesting our food. We're going to run into a lot of things that we're going to see are, common, or we think are issues that we're never going to be able to figure out because it doesn't make any sense. So let's say our stomach acid's working, we're getting the right nutrients, we're digesting, we bought Micah a coffee, and we're actually getting protein into the system. That's what's going on right here. See, the protein's coming in as these little boxes or crates or tanks or whatever they are, and it's going this way into the system. Now, these other lines that are coming in are when our methylation system runs, it's recycling it. See this green circle? It's going around, being used, coming back, and being converted back into protein. And if we don't do that, we're not running all of the systems, and all these processes aren't making the right byproducts and whatnot. See, this is where we are in Seeking Health's pathway planner. And that's what all of this is a replication of mainly Seeking Health's pathway planner. And instead of just looking at it as charts and whatever, we're looking at it as factories and how they convert things and whatever. So this is the first gene in methylation. It's taking protein on the left and it's converting it into SAMe on the right. And we can see right here in this fancy diagram, see protein, ATP, magnesium, SAMe. There's the ATP that's made from other biochemical processes, like in our mitochondria. There's magnesium, which looks like it's low right now, but we'll just ignore that number. I didn't prepare for this. Magnesium depends on our electrolytes. There's a whole bunch of information in here that will make sense to a lot of people if we start paying attention to how these things are all dependent on each other. Sorry if I'm not getting some of these in view. I'm trying to not spend 4.5 hours talking about things that are actually just sort of sideline. So when our electrolytes are working and magnesium can function and we can get it to this MAT1A gene and we're getting ATP because we're actually moving around and the whole system's working to some degree, and we have stomach acid and digestion and we're getting protein and we're bringing it in here, we're actually making SAMe. SAMe has a couple other names. You got this S-adenylmethionine, and here's some other ones. This is really important. This is for the norepinephrine things and dopamine, serotonin, melatonin. A lot of people are looking at benefits of melatonin, thinking, supplementing for the rest of their life is going to be handy, but maybe we should just get the machine running that wants to make melatonin on its own. Not saying that supplementing it here and there isn't bad, but we should probably not depend on those things too much. SAMe is really important. DNA, RNA, proteins, lipids. People are having problems with fat metabolism. This is part of lipid. Looks like we run into some bad things if SAMe is not working right. So once we're making SAMe, it goes through the system. This is methyltransferase. See, our cortisol increases this. BPA from plastic, tea and stuff lowers it. Methyltransferase sounds scary, but it's just a set of processes that use the SAMe, so it's transferring it to them. This is our histamine, one of our histamine genes. This is the one that handles the histamines that our body makes while it's doing these biochemical processes. This doesn't really handle the stuff that comes in from our food. So the SAMe then goes to this DHPR, which recycles BH2 back to our folate version of this DHPR thing, and then folate sends this BH4 back to us. BH4, if you go research that, is involved in a lot of mental health things or a good bit of health problems. So we've got the BH4 and the SAMe coming in and going down these lines of stuff right here. We've got calcium, B2, iron, some other nutrients are running all of this, and we're generating just a bunch of important stuff. We don't even need to really worry about what these things are. Tryptophan we've heard about, and 5-HTP, that's the active form of tryptophan. See, it came in over there, came across that thing, got activated, and now that's actually what comes down here and makes serotonin and melatonin and all the things that go along while those are being made. This L-DOPA is making dopamine. We've got our COMT gene over here. There's some vitamin C. We've got our MOA MAOA and MAOB genes and some nutrients that they use. The hydrogen peroxide that they generate is being sent down to get processed somewhere else. The reason I made this area look all complex like this is because it is. COMT, we're looking at fast and slow COMT, but ignoring the complete cluster that it's a part of. So some people are drinking like 4 cups of coffee a day and sending a lot of different processes through this system or the COMT system and just slowing it down or inhibiting it, or they've got major hormone backups and don't have enough CDG and DIM processing it properly. If we're low on magnesium, here's another area that it's going to get hit. There's just so much going on where all of this stuff backs up and depends on each other. Let's look right here. So people say, well, if I supplement a bunch of melatonin, isn't my body going to stop making it? And it's not that the body stops making it necessarily, or that's the issue, because our body's not going to make it if we're supplementing a ton of it. The problem that happens is as our body's not making this because we've piled up a pile of supplements, this stuff here isn't happening. So we look at it as, oh, well, my B5 isn't doing anything. The B5 has no function through this, which isn't, this line's not running because we're just supplementing melatonin instead of figuring out how to get this system running the right way. So whether serotonin isn't running right, the tryptophan's not coming in, whatever it is, these pieces aren't being fed or they're not being depended on and they're not running. And then these other byproducts aren't happening, and it's just a problem. It's a factory. It can't function right when the pieces are all backed up and we're not using them. We're putting drugs here and there and supplementing these 5 supplements, and we're not looking at the rest of the system and understanding that all of these things that are happening are they're important for stuff that we need, and then they're also making byproducts that are coming back. So SAMe goes in, does all that stuff, and all of those things when they're done are sending back this SAH. And the SAH is coming in, goes and takes care of some regulating our breathing and heartbeat and stuff, not too important. And then it makes homocysteine. People look at homocysteine as a direct problem. They think homocysteine is the issue. It's the fact that either that stuff's not running and homocysteine isn't being generated. The system down here, glutathione, isn't asking for homocysteine because it can't run, or the homocysteine isn't being recycled back into protein so it can run around the system again as SAMe. So there's 2 ways for homocysteine to get back to protein. We've got the one in the middle here, BHMT, and that takes the homocysteine back up into protein, and along the way, it's using these things here. Choline, betaine, glycine, folate, B2 are helping SAMe and SAH balance. So I've supplemented these things in here and not felt anything, and then I've made progress with just general methylation and everything, getting whatever other supplements to help me over months and years, and then I supplemented these again, and they sent me flying because they were helping balance SAH and SAMe, and then I was sending it over there and making a bunch of dopamine or whatever it is to feel better. But then once I was done with that, I had to clean all that stuff up because I made a ton of it at a higher rate, and then I had a bunch of it to clean up at a higher rate, and I got to feel what feeling high on life is like, and then I got to feel what it's like when people don't want to continue living because everything sucks, and it's like you completely lose these neurotransmitters that keep you afloat in finding dopamine in anything normal or whatever it is. It was interesting to feel those balances, and that's what really feeling that and actually seeing Ben Lynch's diagram that puts all of this together was just, it started clicking, and I was like, oh, this is actually pretty easy. So BHMT is one, and then this mTR gene is another one, and this is where I see a lot of people getting confused and misguided. We've got homocysteine coming in, and depending on folate, B12, zinc, and some other stuff along the way for the folate to be activated. But without homocysteine, all the stuff that we've been talking about so far, not getting enough protein in through stomach acid, whatever it is, if we're not making enough homocysteine, this thing right here isn't going to run. If the homocysteine has no function because the system's so broken, there's no reason for this piece right here to continue moving and making pieces and parts. So people are looking at this MTHFR gene and blaming it for all these problems when maybe there's no demand on it. And maybe our body is mutating this gene because Why would we run this gene at 100% when the rest of the system is going to get hurt from those processes being made because it can't handle them safely? Those things end up becoming damaging, almost like a nuclear power plant trying to operate without being maintained properly. We can't just fire the thing up at full rate. We have to like fix stuff and get it all running. So we're running into these like really horrible problems when MTHFR is not running properly, and we're assuming that it's the MTHFR itself. Well, maybe we should focus on some more of this, because as we're going to see, some of these other nutrients have the same problems. They're more important, whatever it might be. This stuff is so intertwined, and we're ignoring so much of it and getting stuck on these little tiny pieces. And yeah, I'm adding a lot of complexity to this, but if you want to fix these things, this is how I did it, and it's possible. And I think there's a lot of people out there that are looking for this and just need to know that it's possible and just need to find the information. These pieces that I'm linking up in here are just like, this is stuff from my bookmarks that I've had time to load into this as I'm sitting here with a couple hours at night before going to sleep or whatever it is. I haven't even really linked these up in a great way to show exactly what's going on. I'm just trying to run through here and show you guys like an overall sense of what's happening. Okay, so we've now covered stomach acid, digestion, methylation, and what SAMe actually does with dopamine and all that stuff. There's so much more to get into those, and this factory is going to allow me to focus on each of these and make a video about those specific things. So when we cover these things in the general video, when you have questions about a specific thing, let me know, and then we'll try to make a video of that at some point. But I got to rebuild my computer first, because it is so frustrating to move around this thing and try to actually, like, you know, not lose your mind while trying to pay attention to the stuttering screen. So this is some information about glutathione. Talking about glutathione is a whole series of videos by itself, but I'm gonna just try to like give the real basic general view of what's happening with glutathione and the problems that people are having. So this big wheel of glutathione, the blue on the ground, is, or maybe purple, I don't know, is glutathione coming in and either being generated or recycled. There's kind of two glutathiones almost. We make one and then we recycle another one. Or they're kind of the same thing, but there's two processes. We're making it and then recycling it. Kind of a confusing aspect, but if we just sort of ignore it and look at glutathione as one, it's a lot easier. So we have this glutathione going around, being used, coming back, and being reactivated, essentially. And then we've got new stuff coming in. The new stuff coming in is starting as homocysteine, and B6, and I don't know what happened to my serine for the CBS gene, are converting the homocysteine into this next thing, whatever CTH is. Along that, it's also sending some stuff over to our Krebs cycle, which is how we generate our energy, how we burn our sugar, and we make all this stuff, and that's how we make our ATP, which is what then runs that magnesium again. So then we come down and make this cysteine, and the cysteine goes over here, and it makes taurine, which is extremely important. If we start looking at what taurine's involved in, it's actually some pretty amazing stuff. Taurine does not get used to make proteins, which makes it a little bit different, but it's the most abundant amino acid in pretty much every tissue in the body. So it sounds like it might be kind of important. And the problem that we run into, I'm going to kind of reiterate how these things work, is we're not going to make taurine if we're not breaking homocysteine down along this line on the way to make glutathione, because we're not digesting our protein, we don't have enough magnesium, we're not running our SAMe, all these processes over here. We're supplementing 4 million pounds of melatonin every day and just locking that system up because none of the other things can work. So, you know, this is what I'm trying to get at. I'll probably repeat it a couple hundred more times. I'm sorry. So now we have sulfite. Sulfites are not good. When we eat processed food, they have sulfites in them. But as this process runs, we also generate sulfites. So now we've created something that can be an issue for us, and we have to run it through and break it down. See, this is some problems we run into with sulfite sensitivities, which are somewhat common, and most people don't realize that. Sulfites have a pretty good list of symptoms. When we have molybdenum and we are generating our superoxide and stuff, which is we're going to go look at over there, this gene runs and breaks it down into sulfate and sends it over to this gene, and it makes PAPs. And if we look back at our melatonin and serotonin, we have PAPs right there. So that PAPs is coming in from what we were just looking at before I zoomed, and it's running this. If we're not making PAPs, this doesn't get to run, and this system over here gets backed up. So now that thing gets backed up, and it makes this not run right, and then it's not running this right, and now everything's backed up on itself. This is where the system shouldn't be getting like this, but it is because of what's going on, which I'm not going to touch on in this video. But when we supplement these different pieces and we carefully feel our body respond or not, what we might be doing is breaking down these backlogs, creating the byproducts, sending them off to where they need to go, and creating whatever's happening over there, and then making the stuff that comes back, and now we're running this better. That's the reason I go super slow with this stuff, because if I need one of these and I supplement it and I start feeling better, there's a really good chance that it's going to go send something way over there, and now who knows how backed up that is, how much other nutrients I need to get that running right, or whatever it might be. So I see people loading up on a couple nutrients, stacking up on them like crazy, and the whole entire thing is backed up. Then they go touch a nutrient way in that system, and this huge pile of stuff goes flying through, and they feel like crap. So instead of loading up on one thing forever, seeing if that's going to work, and then switching to something else and loading up on that, and switching to something else and loading up on that, maybe we should just go slow. And if the nutrient doesn't do anything, maybe our body doesn't need it yet. If nutrient does something, we should still go slow, because it might be helping us catch up on a ton of stuff that's going to go do who knows what. So let's say we have glutathione functioning because all that stuff's running. Now we're going to look at something that's like insanely important and actually starts getting pretty complex. This glutathione wheel is sitting right on this other oxidation wheel that is also our thyroid hormone activating wheel, and a bunch of other stuff that we're going to look at. But what's really important about this is where we transport and activate iron. Iron, people think we have a problem getting enough iron. We absorb like 15% of the iron that we eat. It's not the iron itself, it's the machine not twisting the pieces up the right way to get iron and the nutrients that iron needs to the point that it can actually get the oxygen activated. What in the world is going on here? So this is our NOx gene, which is NADPH oxidase. Bunch of words there that are kind of hard to say. Maybe not, but for me. This thing is like super duper important, to the point that if you were to pull up this page here and like scroll through it and start reading, it's actually not super duper complicated. I mean, it depends on how much of the stuff you read, but like it's just, I could lay screens out all over this place of little tidbits that are pretty amazing. But the reason for that is because this thing is sitting in the middle of like our system. It's dependent on a bunch of stuff that all needs to work. So that's why it's so important. If all these things don't work and can't fuel it properly and it has no demand, then all of these horrible things start happening, because it's a core integral piece. That sends some superoxide down to our SOD gene, which is going to break it down, our superoxide dismutase or something like that. We're going to see how that's important too. And that's the same thing. Whether NOx isn't able to run and it's not sending stuff to SOD, or SOD's not able to run because it's missing some of these nutrients or whatever, things get horrible. So here's where Lyme disease has some information to show that bacteria from Lyme disease are eating up the manganese that feeds the SOD gene. So instead it uses iron and it oxidizes the crap out of it and turns it into this like super oxide horrible thing that's really hard damaging for us. So instead of, breaking the core piece down and sending it over to our thyroid and all that stuff, we're generating oxides, which is horrible. We're working against ourselves because we're not, that manganese is not able to step up and handle the stress of what's going on. So our body has to switch gears and use iron by mistake, most likely, but that's what's happening. And that's a great example of how these things work. A bacteria is eating up our manganese and iron is getting used. If we're missing other nutrients along the way, other stuff is happening the same way. B12 is, there's information you might have seen in one of those screens that B12 might handle just as much SOD activity as SOD does. So these things are like super duper handy sometimes. All right, so let's look at iodine real quick. These numbers are studies that show these things, and I got lazy and stopped over here. This is on my website. I don't even remember the page for that right now. I'll have to add that. But yeah, iodine's connected to a boatload of stuff, partially because of what it's doing right here, where now it's coming through and, working with selenium, which has its own set of stuff. There's even more than that. And that's going into our TRX gene, which is reducing hydrogen peroxide, which is coming in from that red pipe over there. And I think our B12 is making that too. So the hydrogen peroxide is being broken down to oxygen, and the oxygen is going down this line where this catalase and MPO gene are using copper and whatnot to get that oxygen to iron. What we're looking at here is actually our cell maintenance. So it's getting the oxygen from hydrogen peroxide, but these genes are actually also involved in our breathing, are like converting oxygen from breathing, respiration, into, onto our iron, which I thought I had one here for you, but I must have got rid of that, saying that the catalase is part of respiration. But I guess that's not really too important to drive home. That has words, and there's some more words in there. My eyes are getting pretty tired, so you're on your own. And you are here in the pathway planner. Pretty cool. So that's kind of it, in a sense. This is, oh crap, when am I supposed to be in here? This is a huge part of our metabolism. If this isn't running right, people say, don't eat too much protein. What is too much protein? Because if we don't have magnesium and selenium and iodine and blah, 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 everything is too much protein. We can't digest it, break it down, convert it, whatever it is. So we're saying all of these things that have merit, but not when we're ignoring everything else. We're focusing on one little tiny piece and ignoring everything else and wondering why that one little tiny piece isn't working. If you go do that with anything, anywhere, any component or whatever machine system or something, you're not gonna get very far. This is like, I used to fix people's computers, and one of the best examples I had of people not understanding how things work or not paying attention or whatever is I had somebody call and say they couldn't get their email. So I go to their house and I go to their computer and I'm sitting there for a couple minutes and I go out and I'm like, the power supply on your computer is dead. Like I can't get the computer to turn on and it's the power supply. And she's like, yeah, I can't get my email. To this woman, she was walking in that room to get her email and she couldn't get her email. So she called me and said, I can't get my email. The problem was that the power supply on her computer didn't work. This is just a decent example of how we can be looking at something, not to say wrong, but incompletely. She doesn't care if the power supply works or not. She can't get her email. And that's what we're running into here. People are saying, you're getting too much protein, but ignoring what that actually means. And if we ignore that, we might reduce our protein, which is just inhibiting the system even further, instead of figuring out why magnesium's not being suspended properly or whatever it might be. So yeah, that's a lot to take in. But this is really cool. This isn't even all of it. I have another animation that I need to get together to show you how this is just technically one cell, and we're trillions of cells, and these cells are depending on each other. The problem is we're filling these cells up with garbage, and they're clogging up, and they're not able to run these things. So we've got to support the system the best that we can to get those toxins out of the cells so they can be rebuilt so we can fuel the system. And all that means is we need an exorbitant amount of nutrients, or we're not going to get ahead of the curve. We've got a ridiculous amount of toxic input today. We're stressed out beyond belief. We're working so hard against these systems, and we're wondering why they're not functioning. There's more to this than just nutrients. This gets into sunlight, water, electrolytes, which is back into nutrients. It's all together. The problem that we're having is we're trying to live on a toxic planet that is not a natural environment to our system. The fact that our system is still chugging through this is incredible, except the problems that we're seeing today is because some people's systems are not able to chug through this anymore. And all we need to do is help whoever is not able to figure this out get to the next step of this, because nobody seems to understand this. And the information is sitting at our fingertips while people suffer. And that is ridiculous. So if you enjoyed this, I could use your help. I'm just a person that fell chronically ill after falling for a flu jab. And when you go from being normal to chronically ill, you tend to not make as much money because you can't really go to work and stuff. So that's kind of where I am. But I'd like to get this out to a lot more people. And the reality of the situation is I can't really do that myself. Like, without you guys somehow helping, whether that's just sharing, commenting, giving feedback, whatever it might be, this is just going to sit here because nobody really cares about health stuff. And if you've been paying attention to the stuff that's coming out recently, we're being censored like crazy. I've been doing this for years and I've connected with a lot of people. I should have a lot more people following me than I do. And this isn't some kind of race for followers. There's people that want this information and they're not able to get it because very few people share it, and the ones that do are being censored. So do what you can to help get this to people. Once I start making these videos a little more organized and compact and stuff, we're going to be able to get them out to a lot more people, but that's going to take time. Once I build a new computer and get that running, I'm going to be able to get a lot more going, but I could really, like I said, use your help. Hope you enjoyed. I'm done rambling. Let me know what you want to dig into next, and hopefully I'll have some stuff for you beginning of next year. So thanks for watching, and take care.